Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook, question 55. And we have this cantilever beam that is acted upon by an 8 kilonewton force at point B. And we know the angle theta is 35 degrees, and we need to determine in the A part the moment about point O. And in the B part, we need to find the moment about point A. And in the last part of the question, we know that theta can vary from 0 to 360 degrees, and we have to find the maximum possible moment about point O. And also we have to find the values that we can have for theta in order to have this maximum value for the moment, and we also have to find the magnitude of the moment. So basically we have a 2D question, and we're going to use the 2D shortcut that we have for finding the moment. But before that, let's just find out some of the angles in here. So if we consider this as our horizontal or a dotted line parallel to our x-axis, we know this angle here is 30 degrees, meaning this one is 30 degrees too, since we have two parallel line and one's crossing, so these two are the same. So we have this line that is perpendicular to the OA part of this beam. So basically this angle here would be 90 minus 30, which is 60 degrees. Same thing here, we know this angle is 45, and we have this perpendicular to AB. So if you wanna, so we have this dotted line here. So if you wanna find this angle here, we basically have 180 minus 60 minus 45, which will be 75 degrees. And now that we have this 75, this angle here would be 90 minus 75, or 15 degrees. In order to dissolve it in x and y component, let's consider this dotted line again parallel to x. We know our theta is 35 degrees, so we know this angle here is also 15 degrees. Based on the same principle, we have these two parallel lines, and we have the same thing, these two are also the same, so 15 degrees. And we know that theta is 35, so this angle would be 35 minus 15, which will be 20 degrees. So now we can dissolve it into x and y component. This will be our x component, which is basically 8 cosine of 20 degrees, and we have this one, which will be 8 sine of 20 degrees. So now that we have this, all we need to do in here is just so let's go with the A part, finding the moment about point O, and we're going to call it counterclockwise positive. So we have the moment of 8 cosine of 20, which will be in this direction. So counterclockwise, we have a positive moment, so 8 cosine of 20 degrees, and we have to figure out the distance. Well, let's just show that beam in here, we can see it better. So it's now point O, this is A, and here we have where the force is applying, and we figure out this angle is 15 degrees and this angle is 30 degrees. And here are our x and y component. This is our x and this is our y. So we are trying to find a moment about point O. So as I mentioned, the moment of the x component, as we can see, is in this direction about point O, so counterclockwise positive. And the vertical distance that we are looking for is basically this is the line of action, and we are interested in this distance, which would be basically this side of the left triangle minus this side of the triangle on the right hand side. And we have the hypotenuse for each of these right triangles. This one is 4 and the other one is 3 meters. So if we want to find this distance that I showed in red, we basically have 4 sine of 30 degrees minus 3 sine of 15 degrees. So that's it for the x component of 8 kilonewton force. And if we look at the y component, we can see that the y component is making a clockwise moment, so we have a negative sign in here, minus this time 8 sine of 20 degrees, and the distance that we have is basically what we have from here to here, or the base of the two right angles that we have. One of them is 4 cosine of 30 degrees and the other one is 3 cosine of 15 degrees. So if we calculate this, we get from the first one 9.2 minus 17.41, and that's going to give us minus 8.21. kilonewton meter, and that's pretty much it for the A part. Let's move on to the B part where we need to find the moment about point A. So everything's the same, but this time, as we can see, the x component about point A is going to make a clockwise moment. So negative minus 8 cosine of 20 degrees times the distance that we have is pretty much this distance, which we figured it was 3 sine of 15 degrees. And again, we have the moment of the y component, which is this one. Again, another clockwise moment, so negative minus 8 sine of 20 degrees. And the distance would be what we have from here to here, which is 3 cosine of 15 degrees. And if we calculate this, we get minus 5.84 minus 7.93, and this is going to give us minus 13.77 kilonewton meter. And that's the answer for the B part of the question. And the last part is where we have the maximum moment about O. So we're going to show it with max. And we previously solved question regarding the maximum moment. And we know we have for moment cross product of R and F, which is R times F times sine of alpha. Alpha is the angle between R and F. And in order to have this maximum, it means that the sine has to be maximum, and when we have alpha 90 degrees, we have the maximum of sine or maximum of the moment. So if we get back to here, basically there are two scenarios that we have maximum of 8. So this is the R or position vector, and there are two scenarios that we can get maximum. First of all, our 8 has to be perpendicular to R. So one scenario is this one, and the other scenario is this one. Which one of them makes clockwise moment and the other one is making counterclockwise. So regardless of the direction, we have 8 times this distance, which is our position vector or distance vector R. So let's figure that out first, then we can find the maximum moment. And for that, we're going to use the trigonometry. So basically we have, again, this is O, this is our A, and this is our B. So if we get back to the angles that we have in here, if we want to find this angle here, we figured that this will be 180 minus 30 minus 15, which is 180 minus 45, which will be 135. And let's call these two angles alpha and beta. And we know this side is 4 and the other one is 3 meter. So if we use a law of cosine, we can easily find OB, which will be OB squared is equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of 135. And from here we can find our OB, which will be 6.48 meter. So now that we have this 6.48 meter, and if we do the law of sine, so if we do the law of sines in here, we basically have OB over sine of 135 degrees is equal to 4 over sine of beta and 3 over sine of alpha. So it's easy, we know our OB is 6.48. So basically, if we consider these two, we can find sine of beta is equal to 4 sine of 135 over 6.48. And from here, our beta would be sine inverse of this amount, which will be 25.9 degrees. So that's our beta, and alpha would be, basically, we can consider these two for finding the alpha. So sine of alpha would be 3 times sine of 135 degrees divided by 6.48. And from here, our alpha will be 19.11. So now that we have that, so let's go over the two scenarios that we can get the maximum moment. So one of them was this one when we have our 8 kilonewton here, and the other one was this one. And each of them, this force is perpendicular to this one, and here we have the same thing. They're both perpendicular to our OB. So one of the theta that we have in here is this one, which we call it theta 1, and the other one is this theta, which we can call it theta 2. So we found our beta. Since we found beta in here 25.9, it's easy to find this angle here, which will be 90 minus beta, or 90 minus 25.9, which will be 64.1 degrees. So if that's the case, this one is also 64.1 degrees. So look, finding the angles is now pretty easy. If you want to find the theta 1, we basically have 180 minus 64.1. So we are trying to find the theta 1, which we have this line 180. Basically 180 minus 64.1 is going to give us theta 1, which will be 115.9 degrees. That's one of the thetas when we have the moment downward, like downward-ish, because it's a little bit lean toward the left. And if you want to find the theta 2, we basically have 360 minus 64.1, which will be 295.9. And that's the two angles that we were trying to figure out. The last part, we have to find the maximum moment, which has been discussed. Is basically our F, which we know is 8 kilonewton times what we found for OB, which was 6.48, and that's going to give us 51.8 kilonewton meter, and that would be the magnitude part of the question, or the last part of the question where we need to find these two. So yeah, that's pretty much everything for this question. That's actually a very good question to cover all the concepts of 2D moment, trigonometry, and whatever we learned from first chapter and second chapter of the textbook. Hope everything was clear in this question. It was a little bit long, but let me know if you guys have any questions. I'd be happy to answer these, and let me know if you have other solution to solve this. And you guys take care. I'll see you in the next video. Have a good one.